Thank you. I'm Jeff Taylor with TechCrunch, and it's really nice to see you all this morning. Thank you for attending an early session. It's well worth your while. It's time for the second annual Space Operations Challenge Pitch-Off presented by the Aerospace Corporation. The continuing partnership, we've been working with Aerospace for a number of years, is born of an understanding that it is in all our interests to increase the pace and breadth of the uptake of innovations into America's space programs. This year, the Aerospace Corporation built an open call competition for space startups working in 5 areas: robotics, autonomous systems, AI/ML, vision systems, propulsion and navigation. Earlier in the year, we took a large number of applications. These companies were reviewed by engineering and science teams at the Aerospace Corporations to identify the most compelling innovations. These companies were also reviewed through a commercial lens to understand the strong company. We have 5 very strong finalists. You're going to see each team give 4-minute pitches, and then the judges will get 5 minutes to grill them. One winner will get expert-led feedback sessions with the Aerospace Corporation, government experts, and commercial space leaders. The winner will be announced at 11:50 a.m. by the Honorable Steve Osakowicz, CEO of the Aerospace Corporation. Stick around for that. It'll be compelling. We're grateful to have deeply experienced judges with us today, and I'd like to welcome to the stage Cody Bronkar, Head of VC and Strategic Partnerships at SpaceWorks, Tom Swick, Chief Technologist at the Jet Propulsion Laboratory, Deborah Emmons, Vice President and CTO at the Aerospace Corporation, and Justin Kraus, Head of Applied Tech at JP Morgan. Ladies and gentlemen, let's give our judges a hand. Our first finalist today is Lee Rosen from Think Orbital. As a reminder, Lee, you're going to have 4 minutes to pitch, followed by 5 minutes of questions. Take it away, Lee.
Hi, I'm Colonel Lee Rosen, co-founder and CEO of Think Orbital. We build space. We're building tools and we're building large infrastructure to enable low-cost, large-scale, efficient structures in outer space. During my 11 years at SpaceX, we were able to overcome a major challenge of getting things to space. Now launch is reliable, it's affordable, it's super high cadence. For $100 a month, you can have data pretty much anywhere on the planet from Starlink. But what we don't have is the ability to scale or the ability to build anything big in outer space. You wouldn't build a factory on Earth that's 40 feet long and 15 feet wide. There's no way to scale it. But why have we been doing it the same way for the last 60 years in outer space? Something has to change for us to be able to get that scale. And what we're doing first is building the tools to make that happen. A robotic arm and an end effector we call the Think Toolkit. It consists of an electron beam-based welding system. We can do welding, debris-free cutting. We can do X-ray inspection of the weld that we just did, and maybe even look inside a satellite, and additive manufacturing. All of that is easily integratable onto any medium satellite or larger, and we plan to be on a lot of those satellites. All of these technologies have been demonstrated on the ground already, and some of them in outer space. While I was at the White House National Space Council briefing this whole toolkit technology, they keyed in on the X-ray piece. Some of our adversaries may be hiding, say, nuclear weapons inside satellites, and the ability to see inside a satellite from distance is something that would change the game in this mission area called space domain awareness. And our development has some really innovative things to focus those X-rays to be able to look inside a target, get 5-centimeter resolution at 10 kilometers. Again, game-changing. Eventually, we become the biggest user of our technology to build huge infrastructure in outer space, up to 4 times the volume of the International Space Station on a single launch, assembled in weeks. Well, what do you do with that big empty volume? You use it for in-space manufacturing, military depots, habitats. The Think Toolkit and the ThinkX for anomaly resolution, servicing, space domain awareness. We're getting great demand pull from the government. We won the NASA Collaborations for Commercial Space Capabilities 2 contract alongside industry giants like SpaceX and Northrop Grumman and Sierra and little tiny Think Orbital. We've won 4 small business innovative research contracts, including a recent $1 million phase 2 on our X-ray technology. We've got great capabilities and collaboration with all the major government players, including some commercial players as well, where we have letters of intent. As far as financial drivers go, we are experiencing Moore's Law in outer space. The number of satellites effectively doubling every 2 years or so. I don't have to be on every single satellite. I have to be on just a small portion of those with the Think Toolkit to have a very viable business. Add in a constellation for ThinkX and a few of these Think platforms, and I'm a unicorn multiple times over here in the next 5 years. You ain't a real space company until you've flown into outer space, and we have done that. We flew the first ever autonomous welder on the first stage of a Falcon 9. You can ask me about that later. And we are about to fly a long-form welding, X-ray, and cutting demonstration on the 21st of December. And then next year, we'll be flying our commercial product, the Think Toolkit, on a demo mission next year as well. Got amazing folks, military, former SpaceX, and PhD-level engineers. This seed round, we're targeting an $8 million seed round. We've got about $3 million lined up. We're going to be doing prototyping, on-orbit testing to get a sales-ready toolkit for next year and doing R&D on our ThinkX X-ray platform. With that, I am ready for your questions. Ladies and gentlemen, thank you. They were so enthralled, there were no questions. Yeah.
Who goes first?
Perfect.
Quick question up front. You have a deep pot of money, as much as you need, short term. What's the top thing you're going to work on, tall tentpole, that's going to get you over the border?
Yeah, that's a great question. I think getting to a commercial product where I can stand on my own is really important, right? To be able to generate revenue as a young space company, I'm not young, but the company is really, really critical. So using that cash flow to be able to get us to this point where we can start making money on our own and have the government invest a little bit alongside us, that's a great formula. As much as I love VCs, I would rather make my own money than take money from somebody else, frankly.
Actually, and just if I could jump off that, and first of all, congrats, this is amazing. So the $8 million, as you think about that question, what is the near-term capital need? If it's 8 in the seed, how do you see it, and how do you see that play out?
Yeah, so the $8 million gets us a commercial product to be able to go sell, which, again, is my top priority right now. And it gets me R&D on the thing that I've got the biggest demand pull on, the ability to look inside satellites with X-ray, right? Mm-hmm. And it gets me to demonstrating things in space, because, again, you have to have space heritage to really be taken seriously in this business. So using that money to get us there, subsequent rounds aren't huge. I know it's astounding. It's the space industry, right? It's supposed to be billions and billions of dollars, but it's really not. It's just allowing us to scale production, right? And get bigger and bigger, and eventually demonstrate building big things in outer space, which I'm learning along the way by building the toolkit and the robotics. I'm learning how to do that. I'm learning how to weld in space. That enables me to build that big thing in outer space, and that's essentially aluminum, right? And aluminum ain't that expensive. Thanks.
So from the technical product side, maybe just help me out. Again, congratulations, really impressive stuff. Weld and cut, X-ray inspection, and a large platform. Is that, if I'm thinking about your products and the technical products here, are those the right 3?
Essentially. And additive. I'll add additive in there.
So when you say you're going to use the $8 million for the commercial product piece,
right,
is that, which of those 3 do you see? Maybe can you talk a little bit about where you're heading with those 3 from the commercial versus the government side and the key milestones?
Right. Well, that's a long question, and I'm going to give you a relatively quick answer.
All right.
So This thing that we've developed is really a Swiss Army knife of capabilities based on electron beam technology, right? Electron beam welding sounds like it's from the future. It's been around since the 1960s. It's used extensively. We used it at SpaceX to weld the thrust chambers together, things like that, right? So we've taken, an electron beam welding head that's about the size of one of these TV screens, shrunk it down to about the size of a venti coffee cup, right? And that itself can do welding at about 1 meter per minute. It goes really, really fast. It can do debris and thrust-free cutting, which, if you piss me off, I'm going to go cut your solar panels off, and you're not going to know about it till the lights went out. Maybe there's some applications there. Additive manufacturing, I add a little metal in, and I can actually 3D print with it. And then when you take the electrons that are moving at a portion of the speed of light at the end of the gun and slam them up against high-density metal like tungsten, it generates magically X-rays, right? So I have my own X-ray source on board because of the electron beam, right? So that gives me all of those packaged, and what I'm doing with this money is packaging this into a commercial product, basically.
Commercial heavy focus initially up front, right? I mean, all of our questions reflect that as well.
Yeah.
On the government side, what does the right amount of energy spent look like, especially when looking to raise? CapEx, how much goes to that, right? What does that look like?
Yeah, I think on the government side of the house, we're getting great demand signal on this X-ray capability because of these threats that I talked about during the presentation, right? And I want the government to go fund a constellation of X-ray satellites, right? But commercially, there's not really a business there, frankly, right? Maybe there is for close-up inspection if I want to do anomaly resolution or fix something on a broken antenna or something. But for the most part, I got to kind of get the government excited about that, get commercial about putting one of these toolkits on every single medium-sized satellite or larger, right? And then we become quite a viable business in my estimation.
Great. Thank you.
Lee, thank you. Thank you very much, Lee.
All right.
Thank you very. Oh, now
Thank
I have
you.
a mic.
Thanks.
A big hand for Lee Rosen with Think Orbital. Great job, Lee. Great questions, judges. Wow. Our second finalist is Hira Verdi with Lumi Space. Hira, the stage is yours.
Good morning, everyone. That ain't working. So, I guess there's this situation we have right now in space. There you go. Hi, good morning, everyone. So there's this interesting paradox that we have right now in the space industry. We have this overwhelm that's based on an increasing number of launches, an increasing number of satellites. And the reason for that is satellites provide value for humanity on Earth. They provide value through financial sectors, agriculture, logistics. You'll see some of the other companies on the pitch session here talking about exactly those applications of satellites and why they're so important. But combining the increasing launch rate, the decreasing launch cost, with the geopolitical tensions that are arising in space, we have this sense of sheer overwhelm. That operators are inundated by collision warnings, they have uncertain operations. And so at Lumi, we are here to eliminate orbital risk using ground-based lasers to remove the million small debris that no one can do anything about today. That overwhelm today manifests itself in 500 million collision warnings for operators. There is such uncontrolled risk. We speak to some operators who specifically will not maneuver because they couldn't tell you whether that maneuver is going to increase or decrease their chances of colliding with another piece of space debris or another satellite. So there's poor and inconsistent quality data. Current cleanup operations are expensive, and we have a 99.9% false positive in that data that operators receive. So it's a double disincentive not to act on warnings that are received for operators. At Lumi, we are tracking, nudging, and removing space debris using ground-based lasers. And this is a new sector for space. We're calling it space control. We start by tracking with 1,000 times more accuracy than optical or radar technologies. And that's because we're using LiDARs. This, for 60 years, has been the most precise mechanism to track satellites and debris. We move on to nudging. So photons impart momentum either directly through radiation pressure, momentum transfer, or through ablation. And that means we can avoid collisions without having to launch anything. And eventually, that leads to, with several interactions, the removal of debris at scale. The European Space Agency and NASA have both highlighted this as the most cost-effective and the most scalable mechanism to deal with the problem. And so we have 3 phases to tackling this. The first is to deploy tracking aids, like this one that I've got. Right? This is real scale. So by installing this on your satellite, you make it future-proof. You make sure that it's not going to pose a threat to other people's space operations. And this is an engineering model. Right? We're already selling these, and we have these in orbit. Phase 2 is to develop the tracking network, the ground-based lasers, and that's already underway as well. Also to develop the nudging testbed. And phase 3 is the operational removal with 4 of these nudging stations deployed around the world. We're already generating revenue across all of these, from commercial revenue all the way from interesting technology demonstrators, the next phases of space technology, through mega constellations, space agencies, and defense. So we've already got clear commercial and R&D funding across all of these phases. In terms of the team, our CTO, Ewan Schaefer, has designed, built, deployed, and operated the most innovative laser ranging stations in the world. Our CPO, Dave Gooding, has sold space products globally. Our CSO, Dave Bolson, has scaled startups from pre-seed through Series B and worked in the government and national security space. And my background is an education from the University of Oxford and a PhD in modeling the orbits of space debris with the US Air Force. We have a team of 20, and we're still growing. We've got another 10 roles open. And we've bootstrapped to this point. Right? We've not taken private funding so far. So just to reiterate that vision, today we have a Wild West where 10,000 satellites are not operating safely. With Lumi's technology on the ground, with this central LumiX platform, we move to a world where 10 million satellites can operate safely, because that's for the betterment of humankind. Right? Space technology is the bedrock that underpins much of the technology that we rely on as modern society. Let's build a new future for space. We are looking for partners, for commercial opportunities, and for funding. Right? We're always fundraising. I'd begin to chat. Thank you.
You just beat me, Hero. That was the end of your time.
So you guys are UK-based, going to be working in an environment where there is no borders, right? Where there's integration into many other platforms across the globe. How has that integration looked like with other countries and other partners for you guys, maybe in the next couple of years when you guys are fully building out this product and delivering at that point?
Absolutely. So on the one hand, it's about setting up key entities in other locations. Yep. It's also about finding the right commercial partners. So it doesn't necessarily require us to have the overhead of setting up in different areas. We already have customers in the US. We already have customers in Europe and much further afield. So when you have a product that people want, the mechanism to interact with other countries, agencies, customers becomes clear. And so we're already selling into all those markets.
Really neat plan forward. Obviously a very important problem with everything that's going to space. You can just look 5 and 10 years down the road, the issues that are going to come up. So you have sort of an idea here, I'd call it an idea into the proof of concept. What's the first, you know, you're going from ground to space, you got the atmosphere, obviously, you know, high-powered lasers, there's a lot technically going on there. What's the first thing you think you need to do to prove to yourself and then the VC world and regulation world and everybody else that you're going to be able to do this, just proof of concept, first case, simplest approach?
So there are a few different areas to that. As you said, there's regulatory, there's technology, there's safety. On the actual core technology, we have videos of lab-based demos showing what different materials do when you have high-powered lasers shining on them in drop chambers. So kind of simulating or real-world experiments showing the impact of high-powered lasers on the trajectory of objects. Now, as you say, the atmosphere is one of the key barriers to this. So we started off with a world-leading atmospheric turbulence monitor. We're the sole commercial partner with a world-leading university on that. And so that's already being used in optical communications programs, which is our technology. We have direct sales to the comms arena for laser comms. And so about 4 or 5 weeks ago, we were involved in the first ground-to-geo daytime optical feed link demonstration with the European Space Agency, and our hardware was critical to that. So we're tackling the technical areas of atmospheric pre-compensation. On the regulatory, I think it's about demonstrating, right, the reason this is in phases is we demonstrate lower-powered lasers and showcase safe operations over time, and that's what gives us the experience, the heritage, the regulatory approval to go to increasing powers. And also, it goes to Cody's question on how do you interact internationally, right? This is an international collaboration rather than being a kind of sole, right? We don't want this to necessarily look like the military technology that some might assume it is, right? Because there's a bigger goal here in ensuring the safety and sustainability for space.
Maybe building on a little bit on the technical prove out. You talked about the stations or the nudge stations ultimately. So what are the plans and the milestones there in building them out, and where will you be building them out?
So the plan there is firstly to build the test bed, and that is in a favorable location from a regulatory, from a safety, from a resilience standpoint. Once that demonstration is complete, then it's about finding, right, it's rare to find a business in space that's generating revenue that has more than just VC as a funding mechanism. So to deploy these stations around the world, we're already in conversations with debt financing outfits to say, okay, once that demonstration is there, once the customers have already kind of paid for some form of this. So when you have the customer and you have the hardware demonstrated, that's debt financing. That's not VC at that point, right? We would be crazy to be taking dilution. Yep.
And physically, where are you building the test bed? Is that in the UK or in the US?
In the UK at the moment.
What and congrats here. We won't talk about debt financing right now. What from a team perspective, you've obviously built a great team. Is there anything as you think about folks you want or need to attract? Is there a gap particularly you're focused on as you build out your team over the next round?
So I think there are always gaps, and so we look to that international collaboration, to which technologies we develop in which geographies, because the availability of talent across optomechanical, robotics, autonomous systems, right? Our stations are robotic and autonomous. So all of this together means we don't expect to magically find everyone in one place. So we look to geographical diversification for parts that are relevant. Yeah, that's how we're looking at the problem right now. And as a fast-moving company, these things naturally change as you go.
Great, thank you.
And I think that ends our judging time.
Yep.
Big hand for Hero Ever
Thank you
with
so much.
Lumi Space. Hero, great job. Very nicely done. Thank you, judges. Our third finalist is Brian Manning from Zona Space. Could we have a warm round of applause for Brian? Good luck, Brian.
All right. Hello, everyone. My name is Brian Manning. I'm a former SpaceX engineer and CEO and co-founder at Zona. At Zona, we're developing a network of small satellites to provide extremely high reliability and centimeter-level accuracy directly to billions of GPS devices around the world with as little as a firmware update to those devices. So GPS has quietly become the most widely adopted satellite system in history. It is integrated into nearly 7 billion devices around the planet and creates over $500 billion in economic value every year in the US alone. That it has become the backbone of farming industries, of aviation, of automotive, of defense, of so many different things. But something is happening in all those industries, that they're hitting their fifth industrial revolution, that they're becoming autonomous, they're becoming robotic. And these new systems need far higher accuracy and far higher reliability than their predecessors, and they now need far higher accuracy and far higher reliability than GPS can provide. The GPS can support a human operator, but it really struggles to support a machine operator. So how do you fill the gap? Well, the same way that small satellites have filled gaps in satellite weather and satellite communications, they offer the same potential to fill the gaps in satellite navigation. That by using a network of small satellites that are 20 times closer to Earth, our pulsar network can provide up to 150 times stronger signal than GPS, enabling it to reach places that GPS can't. We can get down to the incredibly high level of precision that is needed to keep a car centered in its lane. We can do that through a very high secure modern signal that can let you feel safe taking your hands off the wheel. And something that's most important to a lot of our defense customers is we can do this with a system that can operate fully independently of GPS, filling in a gap for much needed backup in that world. What really enables us to do this is that we have developed and patented a precision time synchronization architecture that enables us to go from the big multi-$100 million GPS satellites down to very small, low-cost satellites. And we have proven that this works. We've proven it works in space, and we've proven that we can do it with low-cost hardware when we became the first privately funded company in history to launch a satellite navigation mission. The real key to success here, though, isn't necessarily the satellites, it's the user equipment. That if you're going to provide a service that can scale up into the billions of phones and hundreds of millions of cars that are out there, it can't require a $1,000 user terminal to actually use it. So we worked hand in hand to develop our pulsar signals in collaboration with some of the biggest GPS chipset providers on the planet. And we have now demonstrated that our service can be integrated into these devices with as little as a firmware update for everything from high performance devices down to very small consumer level chipsets. The real question here, though, is, okay, is there actually a business? I mean, GPS is free, right? Well, customers spend an estimated $20 billion every single year on GPS chipsets and receivers to integrate this capability into their devices. The problem, though, is that the demand for higher performance has continued to increase and to accelerate, but the performance of these devices is now limited by the capabilities of the signals coming from the big government satellites. So unless you have a multi-$1,000 big expensive receiver, there really just isn't much left for an upgrade option. This is where we start to fill the gap. We take all that complexity from those very complex receivers and we put all that on the satellite layer. That allows us to start providing extremely high performance to all devices instead of just a small subset. So we can start to deliver 100x gains in performance to more than 99% of a market that produces over 2 billion devices a year and is desperate for a solution as the technology that it supports continues to evolve. And we've proven that the demand for this is real also, that we're on track to do over 5 million in revenue this year and targeting over 20 next year. A lot of this is from both government and commercial R&D and pilot contracts, and we've built up over $1 billion pipeline that is eagerly awaiting the results of the first production class satellite when it launches next year. So with that, excited to be here. It's something I'm very passionate about, not just because of the commercial potential, but also because of the impact potential and how much this system can do to unlock capabilities in devices around the globe. So with that, I'll turn it over for questions. So. Yeah.
Thanks, Brian. I will take the first one. However, I do have two, so I apologize to the panelists. So I would say the first one would be limitations on the commercial sector. Obviously, this is a growing market and something that you're going to serve at scale very fast, right? What is, in your opinion, the number one thing that you guys would try and serve initially into the commercial sector?
Gotcha. Yeah, so as much as I talked a lot about like autonomous vehicles and that is not our first market. They're just generally slower to adopt. What we have found is the earliest adopters historically of new satellite navigation technologies have largely been in industries like agriculture. What we're starting to see is industries like IoT have a really desperate need that 90% of the value of an IoT device might be knowing where it's at. So as we can start to open up, more often, or having that device know where it's at more often with higher accuracy, you start to unlock incredible new insights for them and other capabilities. And a lot of those IoT devices are also vertically integrated, so they're a lot easier to be able to pick up new technologies and adopt quicker. So in general, we're targeting industries that have less regulation on them early on, and then building into the ones that are more heavily regulated, like automotive and aviation.
So that was going to be my second one, and you kind of answered it, was the main limitation there on the commercial sector.
There's a couple limitations that there's a patchwork quilt of different navigation options out there today. What we found is that you really need to make it easy to adopt. And so if you can make a system that is easy enough to adopt, the demand is out there. So making it accessible, if you have it simple enough to adopt that it's only a firmware level update at the right price point, the demand is virtually unlimited is what we found. So.
Just to jump off that, would you say that is IoT the most surprising market or the most near-term large actionable market, or is there another one that stands out that you guys have identified?
We keep getting surprised. We talked to a vending machine company that was like, well, we want to know if our vending machines are at the end of aisle 4 or the end of aisle 6, but GPS won't go through a roof. And so with our signal being so much more powerful, we can start to unlock insights and even things like that of why did this vending machine make 10 times more money than that one? It's like, well, how many do you have out there? Like a couple million? Like, wow, okay. So the number of things out there that just happen to have several million devices that all want to know where they are with higher accuracy, which it kind of continues to surprise us. And IoT, I think, is one of the biggest growth market areas.
So from a revenue model standpoint, does that change I know you mentioned, I think, ARR in here, but just wondering about, do you see tailoring different revenue models for different end markets?
Yeah, so our goal has been to align our, pricing model as closely to the way that the pricing model exists for GPS today. And so most people think of GPS as free, but again, the precedent has always been, okay, there's a chipset. If you want higher performance, you pay more as a capital purchase for higher performance chipset. So for us, in the markets that are typically used to paying for it as a capital purchase, say, okay, would you pay another 25 or 50% if you got 100x better performance on it? So in many ways, in a lot of those markets, we just look like the highest value firmware update you could ever possibly do to a chip.
Thank you.
So I'm curious, just maybe a little bit, your innovation here is really in the distributed atomic clock. And so it's on a low-cost satellite. You have 258 that are part of this network. Could you take your innovation and then instead of actually building your own satellites, kind of work with somebody else and partner to get them on some other low-cost satellites? I'm just interested a little bit about that pathway you took. Could you explain that?
Very fair question. We've gotten that question. We've explored it a lot of different times. There's a lot of communication satellites going up, for example. The challenge that we found is, we designed everything around the user equipment and said, okay, what does the user equipment need? And one of the things that the user equipment really needs is a very powerful signal. And what that means is that turns into, we need a lot of power on the satellites, which you tend to start becoming a pretty nasty parasitic host to actually try and put on someone else's satellites. So we actually end up having a platform that is more optimized to host other folks, but it is pretty tough for us to be kind of the secondary.
Because you're power hungry.
We're power hungry, yeah. We're generally on the satellite side. That's one of the biggest drivers is power limitations.
Fascinating area. Taking probably the biggest impact government system and trying to turn it commercial. Fascinating idea. 5 years, how many spacecraft do you want to have on orbit? How fast are you going to be there in 5 years?
A lot of it becomes capital limitations. I think at that point we should be about halfway through our deployment. That'd be our target. 5 years, things go right, we could be all the way there.
All in 5 years?
Yeah.
Fantastic.
Yeah, there's definitely paths that get us there. With the right funding and the right support, both from a government and private side. So I think I'm out of time, but
All right,
Thanks,
that's
Brian.
time. Thank you so much.
Yeah.
Our fourth finalist, ladies and gentlemen, is Troy Morris from Kyle Morris, Inc. A warm round of applause for Troy. Good luck, Troy.
All right, good morning, everybody. Do the slides up?
You got a slide issue?
There we go. Oh, can you go back? All right. What's a day without a little tech issue? So I'm Troy. I'm one of the co-founders and CEO for Kyle Morris, Inc. We are capturing the unused value in orbit with 3 services of our innovation portfolio. So this is for the actual backbone and structure of space, the satellite assets themselves. So think of it as a tow truck in space. We're providing logistics and maneuvering for the realities that our customers are facing across the ecosystem. So in space, you've got your average satellite. Designed, useful for 7 years. Actually used, 5.3. Brings in $233 million, but you're leaving $75 million on the table. That missing gap is the difference between having servicing in space and the way we are today. So at KMI, we're working with our customers to how do you use the full depth, the full experience of what you've designed, what you've built, how do you make that fully available for the customer, whether it's purely financial or mission critical to us on the ground. So the services that we're looking at all begin with orbit change. If you're going to do a tow truck, you do a lot more though. So end-of-life servicing, where we prevent these assets from becoming debris in their later life, or for the things that are already there, it doesn't matter. We are working with relocation regardless of mission or hardware design. So whatever the customer has built, whatever they're operating, whatever they're on mission, there's nothing to add, there's nothing to subtract, there's no commands necessary. We'd like it, who wouldn't like it, an easier job? But we're working with the hard and the difficult because that's where we thrive. So our solution that brings this possible is known as Reach. This is a test module of what we are sending up to the ISS next month on the next cargo launch. This came out of NASA, JPL, and a few other partnerships with DARPA, but this is our development that we've patented and we're sending up to station to demonstrate the ability to grapple in microgravity and control an asset that is unprepared. 98% of what humanity has lost into space has no docking system. It is unprepared for docking, and it's our first customer. So this solution gives us that capability so that we can take our innovations and apply it right where the customer needs. So to get there, our path is, yes, this next cargo launch, which I'm nervously waiting for, that moves us into our MVP. Because we're here to disrupt not just because we're doing cool tech, but we're actively raising. So that raise is getting us through this MVP as we have a mostly subscribed round that's going to drive us into this revenue of the first mission. And as we start seeing $250 million at the end of this decade, it starts here today. Well, it started years ago, but who is to say that? So with KMI, our relocation as a service is the stepping grounds of that future. When you look to the edge of the slide, interplanetary freight, asteroid mining, in-space assembly, these don't just happen overnight. We decide, all right, let's start doing that. The rendezvous, relocation, and capture that KMI is enabling builds the bedrock so that humanity can go do those great things we've dreamt about for so long. Now, at KMI, we are working in a corner of the ecosystem that we found rather ignored. We've talked to many customers across the planet and found that they're looking for capability and cost effectiveness. KMI itself is actually priming or has primed on contracts with half of the participants that have already been on this stage today because we recognize that's what customers are looking for, is how do you deliver these capabilities in a low cost and a high cadence so that you can do it again and again. Now, our commercial interest is driving, and I actually needed to update the slide. We are now also working on a $35 million commercial demonstration that is in negotiations. We already have $5.6 million contracted in contracts with over double that already in proposal stages right now. The team is thankfully more than myself. I'm joined by Adam Call, Austin Morris, and then myself with experiences in software with NASA, hardware at the DoD, and myself with critical sales. Our team is guided by experts with decades of time, some of it even in orbit, that are guiding our team with over 200 years of experience, more degrees than we have people, and that's what we're bringing at KMI. So our raise is, again, mostly subscribed. We are using that use of funds for the spaceflight heritage of a free flyer, the recurring model revenue, as well as the non-recurring engineer for that final spacecraft. So judges, I thank you for your time, and I'm excited for your questions.
$8 mil Series A, 24-month runway. And you're hardware intensive. So what does that look like as far as how you're spending that, how quickly you're going to burn through that?
Yeah.
And what's the contingency plan once one of your customers, say it's government or commercial, come in and say, hey, we need you to ramp up a little more?
Yeah, so ramping up is something we love to do. I know from my engineers, they always say, I can do the impossible, I just need more time and more money. Okay. And so it's something that at KMI, we've worked at a capital efficiency piece. Just as much as our customers were demanding, you can't do this for $100 million, remove a piece. You can't reallocate things. If your tow truck to move your car costs more than the car, you're just not going to do it. So at KMI, we internalized and we operate out of the Midwest. We're proud to be in Marquette, Michigan, and it's something that has given us the capability to acquire excellent talent and affordable living rates with a high quality of life and a capital efficiency that has made some of my more coastal peers quite jealous. When our monthly burn is less than their rent, we have a long way to go.
Another important idea here moving forward. What's your moving into proof of concept here, like that picture there? Maybe you have a grappling instrument that you're going to control, but then you have to attach to other spacecraft, which all look different and so on. What have you done in the lab, or some type of proof of concept with representative spacecraft to show that you got the proof of concept, you got your MVP actually ready to move to the next level?
Yeah, that's a great question. So KMI is proud to have partnered with a number of universities, some in the state, organizations. We've worked with NASA Johnson, NASA Ames, AFRL-RV, some other groups that really have those air-bearing tables and decades of experience to test on the ground what we're going to be demonstrating first here in orbit, and then in free flying there later on. So it's been repetitive to an exhaustive attempt. That's why I'm allowed to bring this arm, because it's one of the dozens that our team has made as an ITAR safe version that I'm allowed to fly with, but it's something that we continue to iterate. Is that our portfolio is not just of making a cool arm, it's all the innovation portfolio and the continuing iterations thereafter, so that when our customer does call, it might not be in 29, it might be in 2032, and they'll get the latest version of what we've deployed because they're not stuck with what was at launch date. They're getting the options that are available when they have their problem.
So maybe I just want to understand a little bit about your product pieces. Certainly you talked about the reach grapple arm. Is that the main product?
So this is the furthest developed of our product lines. So it's something that, this was an early innovation that, again, there's the patent piece on, working with DARPA, USC, and NASA JPL, and this is the leading tip of the spear. So this goes onto our optimized spacecraft, the one pictured off to the right-hand side. That optimized dynamic space operations craft enables us to go and do these maneuvers. But there's also the software developed, there's the mission design, so it's something that I could spend 15 minutes talking about the list of things we're working on, but it's easier to start with hard tech. So this is, again, the tip of the spear.
But when you talk about the 35 million commercial demo, what's incorporated in that?
Yep, so that demo would be looking like the right-hand side here. Rather than grabbing a Thor or Geno rocket body, though, that'll be grabbing a quantity of customer satellites that are currently on orbit that they would prefer to relocate to place their next tier of satellites. So it's something that we're looking at that as the option to be demonstrating not just with rocket bodies, which are great, inert, dangerous objects, but with actual active customer needs.
Thank you.
Yeah, thanks, Troy. Really impressive. And just so I understand the numbers properly, 98% of satellites are unprepared for docking right now. And so when you back into the number of about $75 million per satellite is missed right now of revenue because of the, okay. What, so think along those lines, because the near-term opportunity is massive, although you laid out some very longer-term opportunities as well. From a contract revenue standpoint, how do you see that playing out here, especially on that near-term opportunity?
Yeah, so with our customers we're working with now is something that's very familiar. It's as a service.
Okay.
We're looking at this as relocation as a service for our customers, where it's not you pay a massive bill when you run into trouble. Most businesses can't take that hit and they're going to roll the dice. We're instead looking at preventative. You get your AAA service for your fleet, and you know, okay, I'm pushing into that 75 million, maybe it's 150 million. You can push for those extra years because they've already set up with us the contracting to retrieve them at the point of failure. So you can push it all the way through the red line, and they're very excited for it.
Thank you.
Awesome. Great. Thank you, everybody. Thanks for your vote, and come see our table.
Many thanks to all the finalists that have joined us today. I do have a mic again. So thank you to all of the finalists. And our fifth finalist, and certainly not our least finalist, is Chris Pearson from Agile Space. Chris, welcome to the stage.
Good morning. Agile is meeting the acute industry need for faster in-space mobility. For commercial customers, commercial customers need to get to their operational orbit quickly in order to generate revenues and close business plans. Civil customers like NASA need to reach distant orbits and land on other bodies on time and on budget. National security space is now a contested warfighting domain, and as geopolitical tensions continue to rise, the need for rapid avoidance and rendezvous maneuvers is just going to get more and more critical. Traditionally, chemical propulsion has been the answer to those needs, but supplier lead times are now 2 to 3 years and costs have become prohibitive. Electric propulsion has tried to fill that void, but supplier performance has been inconsistent and accelerations are 2 to 3 orders of magnitude slower than chemical propulsion. So quite simply, chemical propulsion is needed for many, many missions, and Agile is now delivering high-performance chemical propulsion in 6 to 9 months. Agile operates the most advanced test capabilities for chemprop in the industry down in Colorado. We are able to hot fire our engines in the near vacuum of space, and we're also able to generate huge amounts of data, gigabits of data during those test fires that give us unparalleled insights into engine performance. We feed those into design evolution, into design updates that then allow us to take full advantage of metal 3D printing for space. In the past, the kind of design, build, and test cycle has been on the orders of months for our industry. With Agile, we're able to test on a Monday, see an issue, update our design, reprint our parts, reassemble and be back on the test stand actually on a Friday. What you're seeing here is the Agile A2200 engine. This is the very first throttleable moon landing engine that's been developed in the US since Apollo. This engine's been used on a number of US landers as well as some international ones. And what you'll see in the difference between is evolution, and this is 3D printing, really showing how much you can simplify the design by, instead of having hundreds of components, 3D printing that complexity into a small number of sub-assemblies. I fell in love with the space industry back in college and moved to the US 20 years ago. I've been lucky enough to build and scale and take to exit 2 other high-growth space startups. I've got an all-star management team at Agile, including my CFO from my last project and my head of business development. We oversee about 80 rocket professionals that are drawn from companies like Aerojet Rocketdyne and SpaceX. And as the space economy grows to the forecasted over $1 trillion, we're seeing our serviceable market grow to over $500 million. Our traction is demonstrated by the fact we've already delivered dozens of engines and built a dual-use sales funnel with a value of over $900 million. In 2020, when we first got into product, our revenues were a modest 120K. They've grown steadily. Last year was just under 12 million, and this year is actually forecasted to be 18 million in revenue. 2025 is looking even stronger with a secure backlog as we go into next year of $30 million. Our dual-use sales funnel is well diversified. Our opportunities are in civil space, military, commercial. Sorry, I've got some feedback here. And we have a clear path to $120 million of revenue in less than 5 years, and EBITDA and cash positivity in less than 3. My challenge now is all about scaling the business. It's not winning business. We are currently entertaining in investors in discussions for an A round in order to be able to do that. And if there are folks out there that are as passionate about growing the business and solving this industry need as us, we'd love to talk to you. Join Lockheed Martin Ventures and join Veteran Ventures. Thank you.
So what are the technical challenges to the scaling that you talked about?
Yeah, so it's 3D printing and its test facilities are our two big differentiators. We actually operate a 3D printing facility up in Pennsylvania. We've procured about five or six different industry machines already and commissioned those to be used, so we can scale that. That's a procurement issue. On the test side, that's a longer term thing. It takes about a year and a half to commission new test stands, and we're going to have to do that as we expand. But the biggest challenge is actually people. It's talent, and it's bringing those in. We need to find them. We've traditionally been in Durango, which, if you know Durango in Colorado, is like a gorgeous ski town. It's worth coming if you ever get the chance to go. And we built a fantastic innovation hub, but there are limits to how much we can scale the business. So we're looking at other facilities where we can tap into a pool of talent. So yeah, the challenges for scale are not so much on the equipment and facility side, it's people.
And if I was just to add to that, then from a capital perspective, you alluded to an A coming up. Like, how do you think about that in terms of the capital needs over the next? And once that A happens, what do you think? When does the B? Like, what's that time frame to be?
Yeah, so we're in a good position where we are revenue positive. We're close to being cash positive, but we're trying to invest in the business. So we have some time. This year's been a really good year for Agile. We thought we needed an A with a value of about 30 million to actually achieve our goals. We were lucky enough to work with DoD. We have a TAC 5 which we're in negotiation for. We had to do a small raise this year, so it's taken the pressure off. And we actually see that we can meet our goals, the 120 million, with actually 20 million raised. So that's the A round. We're actually ahead of things. In terms of a B, it depends on our exit path. The most obvious one is some kind of industry M&A, and if we do that, we don't actually need a B. But if we continue to actually grow the business, and we've got a lot of opportunity to grow both kind of horizontally, so outside of space, more on a terrestrial side, but also more vertically as well, so do some system level work, then we go for the B. But we have options, which is great.
Yeah. Thank you.
How specialized are your systems? If I came in and I wanted something different, is it just a web-based catalog I'm ordering from? Or if I came in and I said I want it bigger, smaller, I want a different fuel, I want a different environment, I want a different lifetime, what's your plan on all that?
Yeah, it's both. So in my previous firms, I've kind of had both sides of it. So there's been a very innovative firm that has kind of struggled to scale and do large-scale production. And then on the other side, I've had a very mature product, and you've lost the ability to innovate. I want to keep both. And you're seeing that in our catalog. So we've got ACS thrusters, attitude control thrusters, down from a couple of newtons all the way up to 4 kilonewtons for kind of big engines. So yeah, there's a good established kind of catalog there. Part of this scaling is going to be to make sure we can actually build in bulk. So we're seeing orders now of hundreds of units, particularly for the DoD actually. But what I don't want to do is the ability to be intimate with our customers and actually innovate. So yeah, we're still doing a lot of development, and that's really what Durango's good at. This cadence that we can design, build, and test at is a massive differentiator, and I don't want to lose that.
Yeah, you do very well with creating a bespoke option for your customers. We've seen that. The question would be more around why wouldn't a company just at some point vertically integrate it? What's the competitive, I would say, selling point to those types of companies? Some of the startups that we're seeing are starting to vertically integrate, create their own prop systems, et cetera. What are your thoughts there?
So it's performance, right? So at the end of the day, you can generate your own product, but can you overnight develop 15 years of operating test facilities, have the AM IP that we built up over the last 5 years? There's a degree of performance that we can give that it's hard to replicate quickly. And with chemical propulsion, ISP is everything, thrust is everything, right? Those extra few percent make a huge difference. So that's how we differentiate. And yeah, to the point before, we need to keep innovating to do that and stay ahead.
Thank you.
Thank you.
Thanks.
Thank you.
Chris, very well done. Round warm of applause for Chris Pearson from Agile.
This one.
And a round of applause for all of our finalists. There's a lot of innovation up here, a lot of hard work, and a lot of science, and a lot of business. So we're now going to take the judges off stage to deliberate. We're going to announce the winner at 11:50. The Honorable Steve Osakowicz will be doing that, so please join us back then. In the meantime, we're going to have panels and more interesting conversations to share with you. Don't go away. Thanks, everybody.